See how JavaScript's event loop manages async tasks effortlessly, allowing complex operations to run smoothly without blocking the main thread. JavaScript runs on a single thread, meaning it can execute only one command at a time. Despite this limitation, it handles asynchronous operations seamlessly thanks to the event loop. This loop allows JavaScript to offload tasks like network requests or timers, enabling the main thread to continue processing without waiting. As a result, the UI remains responsive and logic flows uninterrupted, even when dealing with time-consuming operations. Understanding this architecture is key to mastering modern JavaScript development and avoiding common pitfalls. Without the event loop, long-running tasks would block JavaScript's single thread, causing the user interface to freeze and making the application unresponsive. This blocking behavior delays the execution of asynchronous callbacks, leading to poor user experience and sluggish performance. For example, heavy computations or synchronous loops can halt rendering and event handling, frustrating users. The event loop solves this by managing task scheduling, ensuring that blocking is minimized and async callbacks execute promptly once the main thread is free. This example schedules a delayed log using setTimeout, illustrating how asynchronous callbacks enter the event queue for later execution. Initially, start and end are logged immediately as they run synchronously on the call stack. Meanwhile, the callback inside setTimeout is registered and added to the callback queue after 1,000 milliseconds. Once the call stack is clear, the event loop moves this async task from the queue to the stack, executing async task. This sequence exemplifies how JavaScript handles async operations without blocking the main thread. The event loop continuously monitors both the call stack and the callback queue to maintain a smooth execution order without blocking. When the call stack is empty, the event loop dequeues the oldest callback from the queue and pushes it onto the stack for execution. This mechanism ensures that asynchronous tasks like timers, user events, and network responses are handled efficiently. By cycling rapidly through these states, the event loop preserves JavaScript's single-threaded model while enabling concurrent-like behavior. Here we compare blocking code that runs an infinite loop with code that uses async techniques to keep the UI responsive. The blocking example halts all other operations, freezing the interface indefinitely. On the right, the fixed version uses setTimeout or promises to defer execution, allowing the event loop to process other events and maintain interactivity. This contrast highlights the importance of asynchronous programming patterns to prevent UI freezes and improve overall application performance. To write non-blocking JavaScript, leverage promises, async await syntax, and setTimeout for deferring work. Promises represent eventual completion of async operations, allowing chaining and error handling. Async await provides syntactic sugar to write asynchronous code that looks synchronous, improving readability and maintainability. Using setTimeout strategically helps break up heavy tasks and yields control back to the event loop. Together, these tools empower developers to build efficient, responsive applications by embracing asynchronous patterns. Using async await simplifies asynchronous operations by allowing developers to write code that reads top to bottom, just like synchronous code. In this example, the fetch data function asynchronously fetches data from an API endpoint, waits for the response, then parses the JSON and logs it. This approach avoids deeply nested callbacks or complex promise chains, making code easier to understand and debug. Async await ultimately helps maintain cleaner code bases while leveraging the event loop for efficient async handling. To recap, the event loop is the engine that enables asynchronous behavior in JavaScript, allowing non-blocking execution of code. Writing non-blocking code improves user experience by keeping interfaces responsive and avoiding freezes. Utilizing promises and async, await simplifies working with asynchronous operations, reducing complexity and improving code clarity. Keeping these concepts in mind will help you write efficient, maintainable JavaScript applications that perform well under real-world conditions. If you found this deep dive into JavaScript's event loop helpful, please like, subscribe, and leave your questions or experiences with Async JavaScript in the comments below. Engaging with the community not only helps you solidify your understanding, but also supports creating more content tailored to your learning needs. Stay tuned for more tutorials that unravel the complexities of modern JavaScript development.